Welcome everyone to this workshop entitled Streamlining the Automotive CAE Workflow with Oasys Software. I'm Andrew White. I'm the product manager for the pre-processing component of the Oasys software, which I'll talk about a little bit later. And I'm here with my colleagues Jens Bauer and Rory Bradshaw. And in this workshop, we'll explore how the Oasys LS-DYNA Environment software can help users streamline their entire automotive CAE workflow. We'll discuss the software's capability for setting up crash tests, including the crash test setup tool, which is designed to work with different test regulations and allows for customizing crash tests and running in batch mode. We'll also cover how to use the integrated Automotive Assessments Workflow and post-processing tool Reporter for quick and efficient results analysis and reporting. So we'll cover the following topics. That's just first an overview of the Oasys LS-DYNA Environment software and its capabilities for setting up crash tests, with examples of common test regulations such as Euro NCAP and IIHS. We'll show you some best practice for using the crash test setup tool, including customizing crash tests and running in batch mode. We'll also then show you some methods for quick and efficient occupant injury and structural assessment using the Automotive Assessments Workflow. And finally, how to use Reporter for time-saving automated reporting, including use of templates for different safety protocols. Okay, so first I have a few short introductory slides at the start for some context. I'll go through a quick overview of the LS-DYNA environment before handing over to Jens and Rory for some real-life demonstrations of how this software can be used for streamlining your automotive workflows. So first off, just a quick note about Arup, which is our parent company. Arup is a global company with offices in over 33 countries. Arup's been in existence for over 75 years now and has more than 15,000 staff. So as you can see from the map there, we're headquarters are in London, but we have a big presence globally. Arup is primarily a consultant engineering business, and this encompasses many different factors, a few of the areas that we work are listed here. We also prioritize environmental regeneration, biodiversity, conservation of resources, stable economic growth, and social value. At Arup, sustainability is at the heart of everything that we do. And as such, our business is aligned with UN Sustainable Development Goals, and this helps define how we shape a better world. So let's focus on what Arup does with, in collaboration with the LS-DYNA software. So in relation to LS-DYNA, Arup works in a number of areas. Firstly, we distribute LS-DYNA and support users in various regions. So we distribute in the UK, we have distribution teams in Japan, in India, in the US and China. We also use LS-DYNA within Arup to help solve complex engineering problems on the projects that we are working on. And that gives us quite a unique position in that, as well as developing software, we also use the software, so can really understand how other users that we sell our software to would be using the software and help them out, because we ourselves might face the same sorts of issues in our work. We also help enhance the functionality within LS-DYNA, so we are in contact with developers at ANSYS, and we help them as well, making suggestions for improvements to the software and so on. Finally, and most importantly, we develop our own suite of products that make it easy to work with the LS-DYNA data. And that's the Oasys set of tools. Where it all began. So this video is a video made back in 1984. This was a train crash into a spent fuel flask. It was a culmination of a 3-year groundbreaking project to study the behavior of this flask in impact scenarios. The project included full-scale and scale model drop tests, real target crash tests, as you can see here, analytical studies, hazard studies, and finite element simulations, which is where LS-DYNA comes in, and our software. Arup's been delivering high-quality technical services to this radioactive material packaging industry ever since. And many of the skills first developed on this project in FE simulation, testing, and instrumentation are also employed in our services to other industries. A few other example projects here. We use LS-DYNA, the Oasys LS-DYNA environment in our consulting work for clients around the world in many different applications. This helps us develop a deep knowledge of LS-DYNA and understand the trends in its use. We can then apply this knowledge and experience to better support clients in the use of our software. Here we've got a few examples. On the left there is Elizabeth House. This is a big redevelopment in the centre of London. The project here is to demolish the existing building and rebuild a new high-rise, multi-purpose development of retail and offices. All this while there's live underground tunnels, the London Underground system running underneath there without any disruption. So we used our software to predict construction-related ground movements around tunnels and to validate the new deep foundation design. In the middle there, you can see Sagrada Familia in Barcelona. For this project, we worked on seismic analysis of the proposed design using Arup-developed concrete and masonry material models, which are now present in LS-DYNA. And top right there, we have the new electric taxi that's in use now in the UK. On this particular project, we did structural analysis using LS-DYNA for crashworthiness, durability, and noise, vibration, and harshness. Arup developments in LS-DYNA and the Oasys suite were instrumental to the success of this work, which also demonstrated LS-DYNA's ability to cover NVH and durability in a real-world application, which has big market potential. Finally, in the bottom right, you can see what's called HS2, High Speed 2, which is a new high-speed rail link being built in the UK. And in this particular project, we did some analysis to prevent sonic booms. These have the potential to generate annoying or even frightening noises near tunnel entrances of high-speed railways. We used our software with LS-DYNA to analyze how these sonic booms occur and how the HS2 tunnels can be designed to prevent them. And you can see, particularly with these last two examples, that the electric taxi and the public transport HS2 system, that this also aligns quite well with our sustainability goals. We're looking to look at electrification and public transport and things like that. So a little bit more on how we enhance LS-DYNA. Arup's been working with LST and now ANSYS for over 30 years. Our in-depth knowledge of LS-DYNA has enabled us to enhance areas of the code for a number of important applications. We've also developed the Oasys suite, a tailored suite of complementary tools developed exclusively for LS-DYNA that give the users the power to prepare models, interpret results, and share solutions. The Oasys software adds value to the LS-DYNA experience and is used worldwide by many of the largest LS-DYNA customers. So I'll give you a quick introduction to Oasys. Arup began developing its own software more than 40 years ago in response to our evolving challenges. Today, our software house, Oasys, which stands for Ove Arup Systems, brings relevant, flexible tools to organizations worldwide. Oasys Limited leads the field in structural, geotechnical, and crowd simulation engineering software solutions, and our applications are used across 200 countries by leading designers, planners, engineers, and architects by numerous universities across the globe. So, as well as those applications mentioned previously, we produce expert LS-DYNA software, and that's really what this workshop is going to focus on shortly with some demonstrations. This is fast and reliable software offering advanced functionality used by LS-DYNA users worldwide to ensure quality models and results. I'll talk more about the different applications within the suite in a minute. First, just to mention, we also produce various models for use with LS-DYNA. We have a range of barrier and pedestrian impactor models, some of which you can see on the screen there. So, back to the Oasys LS-DYNA environment and go through the products in turn. So, first off, we have Primer. Oasys Primer is a preprocessor designed to make preparation and modification of DYNA models quick and as simple as possible. So we have extensive tools that help you set up models, manipulate those models, and crucially, lots of validation checks that make sure that when you run in LS-DYNA, you'll be getting the correct results out. You can have confidence in your results. Oasys D3Plot is the advanced 3D visualization package for post-processing LS-DYNA results. We have another program called THIS, which is an XY data plotting package designed primarily for use with LS-DYNA. We have Reporter, which offers automatic report generation for LS-DYNA simulations, images, graphs, summary tables, and more. And you'll see examples of all of these later in Rory's presentation. Finally, we have D3Plot Viewer, which is our new 3D web viewer for viewing LS-DYNA results. So you don't have to have, if you want to share your results with a third party, they can use D3Plot Viewer to examine them themselves. Finally, Oasys Shell provides an easy way of accessing each stage of the analysis. It includes an advanced LS-DYNA submission shell for running analyses in LS-DYNA that gives you easy access to all the various options available when submitting an LS-DYNA run. So, where do we fit in a typical automotive LS-DYNA workflow? First of all, you would have some CAD, and you would mesh that CAD in preparation for a finite element simulation. And after that stage, that is where Primer would come in, after the main meshing. We do have a mesher within Primer, but it's primarily for mesh modification, sort of filling in holes, remeshing around features such as connections and so on. We then use Primer's tools to help complete the body and assemble a complete vehicle before then setting up perhaps many different load cases. This could be for crash simulations, NVH, or perhaps even for computational fluid dynamics type simulations as well. In this, you would then submit your jobs into LS-DYNA, and then you can use our post-processing tools afterwards, D3Plot, TKIS, and Reporter, to analyze the results and prepare them into reports. At this point, I will hand over to Jens and Rory to demonstrate how the LS-DYNA environment can be used to streamline some of those workflows. In particular, first of all, setting up many different load cases for a typical crash type simulation. So over to you, Jens. Okay.
Hello, my name is Jens Bauer. I'm a software developer in the Oasys LS-DYNA team, and I'm here to present the crash test setup tool. The crash test setup tool helps you set up various crash tests according to different regulations. The tool positions the barrier to the vehicle and creates all the surrounding bounding conditions, such as restraints, barrier or vehicle velocities, or kind of contact definitions between barrier and vehicle. You can create your own custom tests, and you can modify vehicle and barrier settings to create your own bespoke load cases for your vehicle. These settings can be saved and reused, making it really easy for you to set up your custom crash tests straight away right out of the box. Now, the tool can be used to set up one crash test relatively quickly, but it's also designed to set up various multiple crash tests in one go using the batch crash test setup tool, which I'll show you today as well. Today, I'm going to show you how to set up two load cases using the tool. Firstly, the IIHS side impact case, and then the Euro NCAP / side impole case. And then my colleague Rory will show you how you can tag the model with some additional information using the primer workflow tool, and then how to post-process all the results using the Oasys Post Suite. Before I go and demonstrate how to use it, I'm going to give you just a quick overview of the setup process. It's a 4-step process, quite simple. As a first step, you need to select the load case, the crash test that you want to set up. We have a list of 25 tests available from 6 different regulatory bodies, and you can use the default values if you want, or you can create your own bespoke tests. As a second step, you then have to edit the vehicle settings. I'll show you how to do that. It's quite simple. It's things like vehicle orientations or ground planes. As a third step, you need to import the barrier model. That can be your own barrier model or some of the default barrier models that we ship with the tool. And then also you need to update those barrier settings similarly to the vehicle settings. The tool will then position the barrier to the vehicle model and set up all the surrounding bounding conditions. And as the last step, you need to check the setup if you want, and you can write out the master file and save the setup. Now I'm going to do the demonstration. Share my screen again. So this is the primer. This is primer 20, our latest release. So not sharing. Edit. Share screen 1. Share. Ah, okay. Yeah, great. So this is primer 20, our latest release, just came out a couple of weeks ago. And I'm going to read in the first vehicle model that I'm going to use. Click apply, and start reading it in. So with this vehicle model, I'm going to pretend like I've never used this before. So I'm going to show you how you can set up your crash tests with a vehicle that you've just never used with the tool. So just to show you how easy it is to use the tool with a new vehicle model. Now this is Primer 20. In the middle, you can see the graphics area with the vehicle model. On the right, in blue, we have all the tools that we provide. Crash test setup is part of this tool set, but there are many other tools that help you set up your model and check it to make sure it'll run LS-DYNA as you expect. In green, we have all the supported keywords. We currently support all of R13 LS-DYNA keywords and most of R14. Now, the crash test setup tool is under the safety tab, crash test setup. I'll open the tool, and this is the first window that we get, where we can either read in a new model if we want, or we can select the current model that we already have read into Primer. I'm going to select the current model. We can also change the home directory. The home directory is used to store all of your bespoke load cases or vehicle and barrier settings that you create yourself. So they will be stored in this directory. Click Next, we go to the main screen. So on the main screen, we have these three tabs: crash test, vehicle, and barrier. Similar to what I showed you on my last slide, it's kind of this free setup process. We can also update some preferences if we want, or we can restart and cancel the tool. Now to the first step, the crash test tab. Here we have the list of 25 load cases. There's a second page as well. And we can filter these by different regulations if we want. For example, if we only want to see Euro NCAP tests, or we can search for different tests. Now, for this vehicle model, I'm going to show you the IIHS site impact test. So if we click on this test, on the right side, we can see an overview of the test. So there's a little image showing you how the test setup will look and kind of all the different parameters of the test. In the middle, we can update these parameters. For example, if you want to change the impact velocity or the height above ground for the barrier, we can do that simply by updating them. They're already pre-configured with the default parameters, so we can just leave them like that. And we have like a quick summary of the regulations at the bottom. I'm going to show you the left side impact because this is a left side vehicle. And yeah, now I've selected the crash test that I want to do. And as the next step, I'm going to go to the vehicle setting. Now the vehicle setting, again, you can see what vehicle model you're using. You can update it, you can read in a new vehicle if you want. I'm just going to keep the same one. And here, in the middle of the screen, you have the small settings panels. So these settings panels depend on the vehicle and on the test selected, and we kind of need to go through them and select all the values for the vehicle. As a first step, we need to check the orientation of the vehicle. Currently, it's in a negative X direction. So we update this here in the orientation. There's also always these green helper buttons here. When you click it, you get some information text about the panel, and it helps you to set it up if you don't know what you need to do for this specific panel. This will help you. And we have these little green buttons everywhere for all the panels, so there's always some help and information text and some images to guide you along the way. And we have these helper buttons all over our software, so there's always a link to either the manual or to some help pages to guide you through all of the different tools that we have. Now we can see that around the wheel axis panel, there's this red border. This means that the values in this panel are currently just not sensible. Right now there's a 0 X coordinates for the front wheel and the rear wheel. So it doesn't make any sense. So what we can do is we can select a part, and the tool will automatically get the X coordinates from that part using the centroid of that part. So I can update the view of the model and then select the front wheel, click apply, and it'll then update the vehicle X coordinates for the front wheel. I do the same thing for the rear wheel. Press apply. And now we have the x-axis for the front and rear wheel. And the red border is gone, means the values we've put in are sensible. The next thing we should look at, for example, is the ground plane. So basically right now it's set to default 0, 0. We can use the sketch function, which is really handy, to see if that makes sense, 0, 0. Yeah, that looks sensible. We could update that if we want. We could select some nodes on the vehicle, on the wheel to update that, but 0, 0 is sensible. Another thing we can do is we can select a part set for contact and alignment. This part set is used to align the barrier and to check for contacts. We can do that for this vehicle model by just going to manual. Auto works as well, or then use the entire vehicle, but manual will speed up the process of putting the barrier to the vehicle. So I'm going to select the part set left, which is just the whole left side of the vehicle. Press apply, and I can sketch that as well, just to make sure I have the entire left side of the vehicle selected. Now these are all the vehicle settings done. We can update the wheel support plane if we want, but we're just going to keep the default options. What we now can do is, we don't want to do this every single time we use this model, this vehicle model. So we can save these options here. We can give it a name, for example, IIHS report. There's the vehicle model, and we can give it a description as well. I can save that. And now, next time I use the vehicle model, I can simply import those settings with this same setting here. I can import that, and it will just apply these values that I already put in automatically. Now we finished the vehicle tab. Next step is the barrier tab. Here we can import the default barrier if we want, or we can select our own barrier model. So I'm just going to select a different barrier model, and then I'm going to import that. Click import, and before the barrier is imported, we need to update the offsets for the elements, nodes, and labels, because we want to make sure that the barrier elements don't have the same IDs as the vehicle elements. So we want to offset those labels. We can just use the default position, the default offsets given by the tool, or you can go in and update those manually. If you want, I'm just going to use the default ones and press apply. The tool will then import the barrier. We can see the barrier is now imported just in its default position. And we're getting a little warning message saying that we need to use the LS-DYNA large format now. So we have all these little warning messages and some like warning info text boxes to give you some additional information about what the tool is doing. If there's anything that you need to know about, we'll tell the user, we'll tell you about it, just to make sure you know. This is really handy and keeps you informed about what the tool is doing. Now we've imported the barrier model, and we need to update the barrier settings similarly to the vehicle settings. Again, there's the original orientation of the barrier model, which is just currently in positive Y direction, so that's correct. There's this red border around the barrier part set for contact and alignment. Again, that's just saying that we need to update this for the tool to run. So I'm going to select just the front face of the barrier. Apply, and then the tool will show me the front face of the barrier and the left, right, and midpoint of the front face. This is just to visually double check that these are correct. And we can click apply, and we could update some other settings for the barrier. For example, the initial velocity. Tool will just auto create it for you. You could create your own one, or you can select one. Similarly, you could create a wheel support plane for the barrier, and we will also create auto-create the vehicle and barrier contact. You could create your own custom contact now, or you can select one, but the tool will also just auto-create one for you if that's what you want. Again, here we can save the barrier settings and reuse them if we want. So you don't have to do this every single time you use a new barrier. You just have to do it once, and then you can reuse it many, many times and just import the settings. Now this is the 3 tabs done. So one last thing before we apply the barrier to the vehicle, is we need to decide where we want to add the newly created keywords to. So we can either add them to the master file, we can select and include, or we could create a new include to add all of those new keyword paths to. I'm just going to keep the master file as the location. And I'm just going to update the view so we can see how the barrier positions to the vehicle model. And when I press apply, the barrier is going to move to the vehicle model. You can see now the left side of the vehicle is colored in red, barrier is colored in green. I'll move towards the vehicle and make contact. We are trying to combine all of the rotation and translations into two separate lines, one for rotation and one for translations. So it's very easy to just look at the rotation and translations that we apply to the barrier. Now the barrier has been aligned to the vehicle, and we get a little summary window where we could just kind of get some information about the initial velocity cars that was created or what parts that were created. We can then write out the model. So we can change the file name if we don't want to override the master file. And then we can write out the model. For example, using a relative or absolute file path, depending what you want. So I can write that out. And now I can look at my barrier and vehicle model in different views. And we can see barriers just touching the vehicle. Now, this was a setup using a vehicle model that we never used before, and you can see how easy it is to go through the steps and do the setup of this new vehicle model. But now I want to show you what it's like to use a vehicle model that you've used before. So we've already set up all of the different settings, and you simply need to select the load case that you want and click through the steps. It's quite a simple and easy process. So I'm going to read in a new vehicle model, a second model. It looks like this. I accidentally read it twice, so I'm going to delete the second one. So this vehicle model looks like this. I've used this vehicle model before, and I've edited all the settings for it. So I'm going to go to the crash test tool. I'm going to open the starting window. I'm just going to select the current model. I'll leave the home directory as it is. I click next, and we're on the main screen again. For this load case, I want to use the Euro NCAP oblique side port impact. Again, if I select the test, there's a screen with all the information about the load case and the regulation. For this case, I want to do a left and right impact at the same time. So basically, the tool will then copy the vehicle model, and it'll use one copy of the vehicle model for the left side impact and one copy for the right side impact. So you can set up both at the same time, and you end up with two models, one for left side and one for right side. Another thing that I want to do is I want to change the height above ground for my barrier model. So right now there's a default of 102, which is just set by the regulation. So I'm going to update that to 0. Now I don't want to do this every time I want to use this test with the height above ground set to 0. So what I can do is I can save this test setting. So I can basically create my own suite of tests, and I can change the regulation if I want, I can change the name, or I can change kind of the custom group. So you can set up your own custom group with updated parameters, 0 height. I can save that. And now we can see we have this 0 height test here. We still have the default one with 102 above ground, but we also have our own bespoke test with 0 height above ground. Now we've selected our load case. Next step is go to the vehicle settings. Now, as you can see here, all of these values are already pre-populated. So for example, the ground Z coordinates, if I sketch it, you can see that's already correct. That's because I've used this vehicle model before, and I've already set up all of these parameters, and I saved the vehicle settings. And then I linked those vehicle settings to the model, to the keyword file. Then every time I use this model within the tool, it'll automatically import those settings. So you can just double check them if you want, but you can be confident that they're correct because you've set them up before. So you just click next and you go to the barrier tab. Here you can just import the default barrier. Again, you can offset the labels. it will import the barrier. As you can see here, just import it in its default position. All of the barrier settings are already filled out because we used the barrier before, because they're all set up. So we're good to go, and we just press go. Now the tool will copy our model. So we have two models, one for the model number 1 here and model number 2, one for the left side and one for the right side. Now we can choose again where we want to write the newly created keywords to. I'm just going to use the master file for the left impact. I'm going to update the view so you can see positioning. So press apply, and the tool will first do the left side impact. So we can see the left side now being set up. That's model number 1. We then get this screen here again with all the summary, what part sets were created, what initial velocity cards were created. We can then write out our model again. Write that out. And then we get to the beginning of the setup for the right side this time. So we can again choose to write the newly created keywords to the master file. I'll press apply. And then does the right side setup. And then we get the summary screen again, and I can write out the right side impact. And now we have two models. With the arrow key, I can move between model 1 and model 2. So we have two models, one for the left side and one for the right side. So you can see how easy it is and how simple to set up different crash tests with your vehicle model once you've set up all the different vehicle and barrier settings. It's simply just selecting your load case, and the tool will set it up for you. Now I'm going to delete the two models, and I'm going to show you how to use the batch tool. So we can still do this faster using the batch tool. So if I go to JavaScript, batch test setup, this is the batch tool. Every row in this window is one setup, and we can simply select the vehicle model, the load case, the vehicle and barrier settings, and define the output files. And then the tool will do all the setups for us very easily and very fast. So as a first step, I'm going to select the same vehicle model that I used just now. And then I can basically use the same vehicle model for every row. So I can file down for every row. I then can select the crash test that I want to use. We have, again, our zero height above ground test, if we want to use that. So there's still our own bespoke load cases that we created. They're available, or we can use any other one of the default load cases that are available. For example, we could do front impact one, or any of the side impact ones. So I'm just going to do, for example, a rigid full-width frontal Euro NCAP test. And then we could also do the IIHS side impact, again, if we wanted to. Press apply. It then filled out both rows with those two tests. We could do many more tests if we wanted to. I'm just going to show you those two today. But you can basically have your full suite of 20 tests set up and ready to run with this tool. You then select the vehicle settings. We can use just our default vehicle settings for this tool. And our barrier settings, we just use the default barrier. Again, you can use your own bespoke barriers if you want. For this test, I'm just going to use the default barriers. And we then define where we want to put our output master files. So I can, for example, call this IIHS. Fill that down, and I can update them. For example, this is the Euro NCAP. So just update this to Euro NCAP. And I can also change the title for these. So if you want to make sure that you have the right title for all of these, you can update them if you want. And we don't have to set this up every single time we use the tool. We can save our settings here to a file. So I can call this, for example, batch input, and it will then save out this file with all of these settings. Save it, and then next time I want to use a tool with these settings already filled out, I can just import them here. So it's quite simple and easy to use. Now when I press go, the tool will set up all of these two load cases in one go, and it will end up with two files, one for each load case. Now you can see it imported the vehicle, then now it's going to import the barrier. This is just a frontal impact load case, and it's going to move the barrier to the vehicle. Now this is the first load case, and now the second one, but I'm just going to show you the output file for that one. So here we have the Euro NCAP output file, and I can open that if I want very easily. And here's our second one, our second output. So you can see you can use the batch tool very easily to set up many load cases in one go. So you can set up a whole suite of load cases in one go very easily. So that's my part of the presentation. I just want to show you how easy it is to use the batch tool and the crash test setup tool to set up all your load cases very easily, very efficiently, and it'll take you much longer to do this manually. And using the tool, it saves you a lot of time, and it will create all the surrounding boundary conditions for you as well. So now I'll hand over to my colleague Rory, who'll show you the workflow and the process.
Great. Thank you very much for that, Jens. Let me just switch back over to the slides. Okay, so hi, I'm Rory Bradshaw, and I'm going to present to you the automotive workflow tool that I've been working on, and it's in part of the latest release of Oasys LS-DYNA. So the version 20, you can find this. And I'm going to particularly show you the automotive assessments workflow, but there are other workflows as well you can use in your workflow to help you be more efficient. Okay, so what is the automotive assessment tool? This is essentially a tool which you can start with in Primer, and it's a way of labeling your model, IDs for either an occupant or different structures and components in your model that will then be used in the post-processing phase. And this will save you a lot of time, so just a small amount of upfront time to label the model, and we've tried to make this as quick and efficient as possible. So anything that can be automated or auto-populated has been set up to do that. And so this creates a metadata file, a JSON file, which is either it's stored in the same directory as the keyword file, or you optionally have can save the data to the master keyword file. And then that metadata is used in the post-processing phase so that you don't have to worry about tracking different IDs for components, say the head or the neck or the femur and all of these components. They're already mapped to their IDs, and so the post-processing can be automated for different protocols you might be interested in. So right here you can see the GUI, that's the interface we've created. We have a vehicle there. I'm going to do a demonstration actually showing you how we can use this in practice for the two cases that Jens has showed. Okay, so this is kind of a screenshot of using the tool. So the first thing you want to do is you want to choose the correct protocol, and we support a range of protocols that we expect car manufacturers to use, but there's actually functionality to add your own protocols. So perhaps you use a kind of custom sort of setup in-house. You have the ability to create your own one and would be able to select this in the drop-down as well. And not only do we support the different crash tests and the regulations, but also different versions of those. And as you can see in this, as we change the regulations, the user interface updates to match what kind of occupants we might be expecting for that particular protocol, as well as any of the additional structural data that is required. And lastly, there's also the option for the users to select the model units, and that's important because it means that when you're post-processing your data, it's in the correct unit. So you know that what you're looking at is correct in terms of what the protocol is requiring. So once you've selected your regulation, we then have the ability to select the required occupants, and we've used a consistent color schema here. So we use the latent color scheme to represent things which the user might want to populate. There's no requirement for them to fill out everything, but anything that they have in their vehicle, that's required by the protocol, they can label and then save that to a metadata file, and that file is then used in the post-processing, as I've just mentioned. As well as adding occupants, you can also reposition them. So let's say you had an occupant and defined it in the rear passenger seat, but you actually meant to define it in the driver's side. You can move those around, and there's freedom to do all of those things. Okay, so now I'm just going to show you these in practice, and hopefully this will be the most sort of interesting part, where you can see how this tool might serve you in your own particular workflows. You can see why we've called it workflows, because that's exactly what they help you with. Okay, so to start with, I'm going to read in a model. I quite like reading in models by just dragging them in. So I'm going to start with the Euro NCAP model here, and I just drag that into the window. We can see that it's opening up. Give it a second or two to open, and then what I can do is click on the Workflows tool, which is new in version 20 here, and that opens up the whole list of workflows. So the one I'm going to show you is the automotive assessment one, but we have others here, so energy tech, check, entities of interest, and many more will be added in time. But as I mentioned, users can actually add their own workflows, and the idea of a workflow is that it's something which kind of follows through both the pre and post processing. So a small amount of effort in the upfront in primer, say, which is the pre-processor, helps you in the post processing so that you can quickly get the results you need. So I'll click on the automotive assessment tool, and that opens here. And because there's no data currently stored about this model, this opens in the default manner. But if it found such data either in the master file or in the master file folder structure in the format of JSON, it would also populate this. And I'll show you that in the next case. So I'm going to select the side full assessment, that's what we've got here. And then it's the Euro NCAP, so there are other options available, but that's the one I need. And then the version 2022. And we can see that this is telling me we need a world SID occupant 50th percentile male. So what I can do is I can either click on the add button here, or I can click on the occupant seat. It opens this pop-up, and rather conveniently, all of the IDs are already matching, and that's the power of this tool, really. So let's say one of these IDs wasn't matching. I don't know, we can add a few zeros in here. Then it would go red, and when I add that occupant, it will show me that it's green in the sense that the occupant's valid, but if I hover over here, it tells me it has latent fields. So if I clicked on it again to edit that, I could see that there's a latent, and if I actually update those back to the IDs that were required, and clicking on update, we get a nice friendly green tick appear, and that just shows us that we've set that up correctly. Now for this particular protocol, we don't require any structures data, so there's nothing shown there. But what I'm going to do is save that to a file, and typically I save that to, I've missed out one step. So if we look at the warning action down here, it's telling me that I actually need to provide that unit system. And so that's just a prompt to make sure the user does indeed tell them what units to use. So you can set the units to millimeters and then tons and seconds in this model. We'll save that to a file, and then I like to give it the same name as the master keyword file, and it's a JSON file. So now that we've created that, we can actually fire out the post-processing tools locally So we can click this button at the top right, and that is D3plot and THIS. And then here we can see we can either start D3plot or THIS, that's the time history post-processing software. So I'll click on that. And now it's sort of connected, it's a connected session and opens up. And because it's found that JSON file I've just saved, it's actually opened up this menu for me. And that's because this toggle here is selected. So it's found the data, which I'm pleased about. So I'll now click on the Automotive Assessment Workflow. And this window appears showing us the regulation we selected, and then we can change the versions. And normally the main thing that changes between the versions is what we call datum. So those are the thresholds between different scoring bands. And again, this shows the power of the tool. All of this information is built in. You don't have to try and find the protocol document and check what the value was and whether it was positive or negative or both, or whether it's changed over time. The idea is that the data is built in, and so try to make it as easy as possible for you to assess. So I'm going to just first of all click on just the head, and it will do a head injury calculation, so the HIC, and also peak acceleration. I could just select one or the other, but I'm going to select them all. And then I have the ability to choose how they'll be presented. So I'm just going to have the graphs on the same page, but there's the option of putting them on different pages, and then choosing to overwrite the existing graphs or appending. So I'll just plot that. And because it's doing a HIC calc, this window appears telling me basically what the HIC window was used. I'll press continue, and then now I can see my head injury calculation has been completed, the score there, and then also we have some metadata here in the outputs fields. So the HIC score is reproduced here, as well as the HIC window and the accelerations. Next, I'm going to now show you how to just sort of do everything else. So I'll select them all, but because I've already done the head, I'll deselect that with a control click. And then we're going to generate the outputs for all of this data here. So because I've already got one curve and I want to keep that, I'll change it to appending, and then I'll plot those. And this is where you see the real power of this tool. So all of these actions and clicks that are firing away, I can wave my hands around, grab a coffee, do whatever. It won't take that long, so I probably wouldn't have time to grab a coffee. But you can now see that it's created all of these beautiful curves for me using the color schema for the protocol. And we could interrogate these. We can now do all of the standard actions that we would use within THIS. So for example, I've got this upper chest viscous criteria curve here, and I can right click on that, and I could do things like I can change the color if I wanted to, or the line style. So we've got full freedom to do all of the standard things. But what's being taken care of for us is really all of the kind of heavy lifting and crunching of generating these curves, ensuring that the IDs match, and particularly something that's can be quite time consuming is, as I've mentioned, getting all these datum set up. But now we can really easily visually see sort of where we've got problem areas. So we've got the chest compression here, and we can see that the chest compression is kind of fairly large in these cases, and so it's going into the red zone. And that, if I was sort of doing an assessment of the performance, would raise a red flag for me, and I would then maybe investigate this more and try and understand kind of how I can improve that scoring and not have to worry about kind of the units that I was using and like whether the datums are correct. So if I wanted to, I could then write out all of these images, and I tend to sort of want to put them on their own pages. So I'll just put them, all the graphs on their own pages. And then now I can write out the images here. So if I just select a folder, I'll just create one, a new folder. I think it's going to let me. And the folder I'll call is the workflow folder. So these will be the workflow images. When this is decided to take a second too. Let me go back to where I was. There we go. So it's created two folders for me. I must have been clicking too much. Okay, so we'll create the workflow images here. And then we'll delete that folder, which we don't need. And then we can just create the output. So this is the Euro NCAP, and then I'll just call it graph 001 to start with, and it's going to generate all of these images so that I can then have them for future reference. Okay, so that was the Euro NCAP. Now let's show you the IIHS one. So this is the other model that Jens showed. And if it wasn't already clear, the step between what Jens has done, which is setting up the crash test models, etc., and this step is actually running the models. And as Andrew mentioned at the beginning, we have this shell software for actually submitting those runs on either your local machine or on a remote cluster. And in fact, Primer also has the functionality to submit models from itself as well. So I'm going to open up this additional model here, and this is the IIHS MDB model. Hold on just 1 second. I just need to find that here. So I have this metadata file. This is a JSON file which I previously created, and I could, if I wanted to, copy that to the location where I'm running this, and that would then store the workflow data. However, this particular keyword file has the metadata stored in, some of the metadata stored in itself as opposed to star n, that's data which is after the end of the keyword file. So when we open this model up and then open the workflows tool, what we're going to see is that some of the data for the structures is already pre-populated for us, as well as the information about the crash test. So here we've got the crash test, so that's the MDB, and then the IIHS and the version already configured, as well as the unit system. And then if we open up here, we can see there's information about the B pillar, and this is information which is important in terms of finding the intrusion at the impact. And so that's already stored for me, but I could update that or manually change it. And then all that's left to do is add an occupant. So I can see that these are sort of latent in color, and so that would indicate that I want to populate them. However, if I look in my vehicle, I see that in this particular setup, I've just chosen to include a left, a driver, so a front left occupant, and there's no occupant in the rear. But the protocol supports a rear occupant, and so if I had that in my vehicle, I could of course add that. So I'm going to select that, and then what we see is we have a pre-filtered product, which is the SID2 model, and also the physiology. And if I wanted to select from the drop-down, I could pick the correct model that's supported. And just to show you this, that I could, if I wanted to, also turn these filters off and have the sort of full selection of the various occupants that are present. But there's nothing to stop you adding your own particular models, because that's simply just a very standard and easy to understand JSON file. But I'm going to now choose this as an LSTC model in this particular one. And what I see here is all of my IDs have gone red. And that's might raise a flag. I say, oh, what's going on? I've got an LSTC model. Why is that the case? Well, that's because often when we include dummies in a model, we need to offset their IDs. So if I just quickly show you that, in the include file structure, we can scroll down and we can try and find our dummy. And here we have our dummy there, but we've got this, what's called an include transform. And this is a fairly standard way of including models, separate files in one model, because you want to make sure that their IDs don't clash. And so here we have an offset, so I'm just going to copy that. That's 50 million. And so now if I dismiss that, and then I use the offset field here and type that in. Oh, I should have selected the correct model there. There we go. So that's why the filters are quite powerful, because if I filter the correct one, then I'm going to get the occupant of the correct type that I'm expecting. And
by default, the filters are set up for you, so you don't need to really worry about that. So I now see that by offsetting, all of my IDs have gone white, so I'm happy about that, and I'm going to save that data. So I'll save that data to the file location that I'm using. So I just, again, like using the same file name, so I'll use that and then change the extension to JSON. And I'll save that now. And then, just like I did before, but I'll do it more quickly this time because we've seen it already, I'll open up THIS. The workflow tool fires up. I click on that. I'll sketch everything. And notice the structures are shown here, but there's no assessment type. And that's because that is, the data for that is produced in D3plot, which I'll show you briefly in a second. So I'll now plot all of this data here. Or I meant to change the version first of all. So it's plotting all of the data, and if I change the version, then it would change the data as required. And some protocols have new data which they change the requirements that they're using. So the different rating versions which also reflect those. So it's now created all of my output data, and I could kind of interrogate it and try and understand where the problem areas are. And now if I go to open D3plot this time around, so I'll start D3plot, and in much the same way, it should fire out the workflow tool and show me that I have this B-pillar information. So I'm going to change to the 2021 version. And now I want to find the intrusion. Now, traditionally, to calculate an intrusion would be quite hard in a model because you have to get a cut section in the right place, and you have to measure the displacement of different parts. But we've actually built a tool that does that for you. So we simply run this, and it will take those inputs that we use on the workflow tool, and it will produce this nice image for us. So now we have this image, which shows quite clearly the initial shape of the outside of the vehicle, as well as the intrusion of the vehicle, so how much it's gone in when the barrier is impacted. We can read off the rating, and we can see it's good, so that means it's still in the green banding that the IIHS protocol requires. And we get the output, so both the intrusion measurement, which is 300.581 millimeters, if you need that precision, and then the height above ground of the peak intrusion. And so that's basically how the tool works, and you can use it to understand the behavior and whether you need to tweak things or how you're performing. Okay, so I'll just quickly come back to the slides now. And I'm going to talk about Reporter. So the workflow tool is something which is used when you're kind of in the investigation stage. You want to quickly understand your results, see how you're doing, get full control over the curves and the data, and kind of maybe tweak it to your own requirements. Reporter is another piece of software we include, and as the name suggests, what it does is it reports the data. And the key sort of principle behind Reporter is that there are various templates which we provide a whole family of them, and I'm going to show you some of the automotive ones. But there's also the ability for users to generate and create their own templates. And I like to think of it a little bit like PowerPoint with much more power. So essentially, every component in a Reporter template can have a script attached, or can have a link to either primer, D3plot, THIS, and it's basically a way of creating a report automatically and then using that repeatedly. So you can see there's massive time savings that are possible. So I'm going to show you not only are the time savings in using this tool, but actually you don't even need to create some of these because we've created them for you. So here we have the Euro NCAP, SidePol, and IIHS impact templates. You can see they're performing the scoring for you. That image there, the B-pillar image intrusion is shown, and so basically this saves you a lot of time in presenting your results, and it's a way of extracting them all in a consistent manner. And at the moment, I'll show you we use the metadata stored in a CSV file or in the master file. But the workflow tool that I've just been demonstrating to you, the intention is for that to link up. So yeah, that will save you even more time because you'll just need to create your data in one place, and then it will work with all of these streams. Okay, so now I'm just going to open up Reporter, and I'm going to demonstrate how this works. Okay, so I open up Reporter and I'm presented with this window which gives me various options of choosing different templates. And I'm going to go straight to the Automotive tab here, and you could add your own tabs. Maybe your company has specific templates that you've created, and there's the ability to do that as well. But here I'm going to, there's quite a lot of options to select from, so I'm going to pre-filter them to help it be easier to find the right one. So firstly, Euro NCAP, and then I'm going to go for the side impact assessment. And I could even choose the year if that was something that I knew to hand and wanted to pre-filter by. And I'm going to look at this one here, the side pull impact. So I'll double click on that. These templates have scripts inbuilt, so they essentially kind of lead you through the process of what's required as inputs, and then the output is the report. So this is telling me that I need to select the input file to start with. And so I'm going to go and point to that. So I've got my input file here, which is the side pull assessment. And then I need to tell it where the results are, which are just, typically these are the D3 plot results, which are stored in the same location as the run. And then it's asking me whether I want to use the data which is stored in the file or to provide my own. So I'll say, no, I would like to provide a CSV. And this is where, in the future, this will be linked with the JSON and it will find it automatically. So I'll select the CSV. And then the side pull impact is actually a precursor to the new far side impact, which we also have a template that does that. And that's going to be particularly important as we move to the world of virtual testing and the kind of requirements of that. So we're going to be keeping up with the way that protocols change and the requirements to make it really easy for our clients to generate the results and the data that they need to understand both their models and also to actually be compliant with what the regulations and the codes are requiring. And so if you're familiar with the far side assessment, there's a particular input which is required, and that input is an output from the side pull assessment. So that's what this window is telling you. It's asking if you would like that information to be extracted and output to CSV. And so I say, yes, please. And then all I now need to do is tell it where I want to output the information. So I'll write that to an images directory, and then I just sit back and relax, and it fires away. And what it's doing, so this is opening D2 plot, which is much the same as the tool I was just showing you. It's doing the same calculations, but it's now built into Reporter. And so it's extracting that information and creating that metadata file used for the far side assessment. And now it's generating the curves in a similar way to which we saw in the workflow tool in IIHS. And once it's done, it didn't take very long at all. We now have the option of choosing how we output the data. So we could output it as a reporter file, and that means that we have full control over various components, can come back to it and save it at will. We could output it as a PDF, and that's quite good for sharing with colleagues and teams, an HTML document or a PowerPoint. So in this case, I'm actually not going to save it out because I'm just demonstrating here, but I could have if I wanted to. And the other nice thing about these templates is that they have kind of some built-in functionality to support things like modifiers. So if you're familiar with the Euro NCAP side pull assessment, there are various modifiers that might need to be set based on certain criteria. And some of those things are can be inferred from the model, and where that's the case, we do the work for you. But some of those things actually need to be provided by the user. And so let's say we wanted to, I don't know, change the pelvis impact here. So we'll say that the airbag didn't deploy correctly, for example. We'll change that modifier, and it also recalculates the scoring. So now if we come here, we can see the pelvis has changed to this sort of yellow color, and the scoring's changed. And then if we come further through the template, we get a summary of the scores, and then we also get all of these graphs produced with the datums. And that's all that's essentially required by the protocol. So it's kind of done all the heavy lifting for us. So I'll now just quickly show you the other assessment, which is the IIHS one. So this is the MDB impact, and you do something very similar. So you need to just select the IIHS file here. And do I want to use star in data? I won't, because I'll select a CSV file that I have, which contains the metadata. And then it's worth pointing out that if you don't have a CSV file present or star in data, it will automatically fire up Primer, which is the preprocessor, to prompt the user to select those options. And that's similar to kind of the workflow tool where we linked up the IDs for the dummies. But in the future, as I said, those two will kind of be combined, and the metadata will be used from the workflow tool. So that's just worth pointing out. Okay, so where are the results stored? That's in the same location. Where do I want to write the images? That's in the image folder that I've got. And now it's going to do all the number crunching for me, generate the curves, and also open up D3 plot and to generate that intrusion plot image. And so if you had a very big model with lots of outputs and data, this might take a minute or two, but it's quite nice knowing that your computer's doing all of this stuff while you're away kind of having a coffee or whatever. So that was pretty quick. And again, I could save the data, but now I've got all of the information here. And in fact, some of these things are interactive, so I can change the kind of axes here if I wanted to. And I can use some of these modifiers to change the performance or upgrade and downgrade my vehicle. And that changes the sort of overall performance. And we see like the marginal here is now reflected here, and the total scoring. This sort of speed dial is actually consistent with what IIHS uses for their scoring. So we've used kind of the same presentation, and it makes it easy for users to see. And then the last few pages are just summary of the scoring with kind of highlighting colors to draw the user to where there might be issues. And then the presentation of the data curves. And that's basically it. And so you could then choose to write out this data and share it with your team. Additionally, some data, for example, the name of the file that we're using, and say the directory and things can be saved and stored in the file, so that it's easy to link them and reference things over time. So I'm going to now hand back to Andrew, who's going to finish off the presentation for us. So let me just switch to extended mode again. And I'll need to just change the screen share to be screen number 2, I believe. Okay, great. I was going to switch to presenter mode here. Do you need presenter notes? No, you're fine. Okay, brilliant. Well, I'm going to hand back to Andrew for the final parts, and then we'd like to invite questions.
Sure. So thanks very much, Rory, and thanks, Jens. So hopefully you've therefore seen how our Oasys products help those products, Primer, D3 Plot, THIS, and Reporter, can help streamline your CAE workflow. you've seen examples of some of our different products and tools, such as the crash test setup, automotive template assessment workflows, reporter templates, and how these save you time and effort and reduce human error. These are just a few of the tools that are available in our suite of products. There are many, many more. So please speak to us at our stand, or if you're online, get in touch via the various contact details that I'll show shortly. So just as a way of wrapping up, I wanted to mention if you're interested in finding out more about our software, or if you're a user currently of our software, we have a conference in Birmingham on the 8th of June, so a month and a couple of months, where there will be simulation experts, industry professionals and academics, all exploring the latest advancements in the Oasys software, and indeed in LS-DYNA as well. Our latest version 20, that Rory and Jens were demonstrating with, was released last week, so you'll see some highlights from that at this conference as well. To register, go to our website, oasyssoftware.com/dyna, and you can register for that event. Finally, I want to mention that a few sort of resources that we have. We have an extensive list of training courses which you can sign up for, and many webinars that have all been recorded, which you can access also from our website and find out lots more about lots of different tools that we use and ways in which we can help you out with your LS-DYNA simulations using our software. Again, access all of these through our website. You can also sign up to our newsletter to keep up to date with the latest news, upcoming training courses and webinars and so on, and interesting tips and tricks and features within our software. Finally, we also have LinkedIn pages and YouTube pages, which you can easily find through searching, so you can keep up with our latest news. Please subscribe to those channels too. I'll leave some contact details up on the screen there. You can get in touch with us or via your local distributor. Thank you very much for attending and giving us the opportunity to present here. Are there any questions, either in the room or online?
Online, there are no questions yet.
Okay.
I may have some, but maybe you can also tell.
Sure. Yeah. Whichever you feel comfortable. Yeah.
Yeah. There's demonstrations in
Yeah.
like
We can do that.
or
Yeah.
Yeah. Just for you, I had some regarding the suite and season. You had the screen. Is it custom or can you change it somehow or remove it or just make fast instead of?
Yeah, you can. Yeah. You can do that. So by default, that's how it generates them. But that functionality is something that actually uses full control over its and the data's set up. But if there are features that the users would find helpful, reaching out to us is the best way of letting us know, and really we'd like to add new features that clients find helpful, and so it's great to have that feedback. So maybe if the tool had the ability to configure its options, then that might be something you find useful. Yeah.
Never haven't tried. I think you said it's only 1 week.
Yeah, it's new, 2 weeks old. Yeah. So, give it a go.
Yeah, we go.
Let's try it first.
Yeah, absolutely. Yeah. Anything else?
Yeah, all the reporting, some questions regarding also if you can compare more than one result, maybe 4 results, and with 4 results, and then different models in one graph or in one report.
Yeah, so you can do that as well. So if you had different models, so long as they're the same kind of protocol. So let's say you were doing a sensitivity study where you had 3 different models and you wanted to get their different side impacts scores. You just simply load all 3 models in, and the tool has an option to do multi-model comparison. So all the curves will appear on the same. Yeah. That's it, just something we have. Sorry to not demonstrate it.
And you also can change the template of the program, or like what's in the home,
In Reporter.
Oh,
Yes.
Yeah, absolutely.
So the way it's configured is that there's a master slide, which is essentially repeated on every page, and you can add your client image, your company image on that one page, and it will appear on every page. Yeah.
You can add text elements, you can add whatever. It's quite similar, as Rory said, the PowerPoint, but with more power.
And there's also coming up, there's a new, as I said, the workflow tool is being linked with Reporter in the next release. And the idea is that the reports will be very modular. So let's say you wanted to create kind of a combined report of using maybe a subset of the assessments, so just the neck and chest images. You will be able to kind of drop in like different pages that have the image data and kind of create your own custom templates. So we know that some clients want the freedom to control a bit more what's coming out rather than just using the one template. So modularity is the next upgrade.